Today we're going to talk about acceleration due to gravity, which we call free fall. Basically, free falling is any object that's falling to the ground on its own, right? There's nothing controlling it. There's no parachute. Just all by itself. Okay. The learning target for today, I will explore how the principles of free fall describe motion under the influence of gravity and apply these concepts to solve problems in physics, engineering, and real world situations like planetary motion and objects dropped from heights. Okay, so acceleration during free fall. An object is in free fall if it is accelerating due to the force of gravity and no other forces are acting on it. Okay, so if you have a ball that you're just kind of letting it go from the top of a cliff, gravity's going to grab that ball and pull it down. Okay, so in this case we use G instead of A for the acceleration due to gravity. And then on Earth, that G is always going to be 9.8 meters per second per second. Okay. So if you throw the ball upward, right, it's going to slow down. Then it would be negative 9.8 meters per second per second. Okay. Okay. So here is a simple question. We have a tourist drops a rock from rest from a guardrail overlooking a valley. What is the velocity of the rock at 4 seconds? Okay, so our givens are the time is 4 seconds, the acceleration is 9.8 meters per second. It did not say that in this in the question, but it did say that it's falling from rest, and it's like falling on its own, right? So acceleration is going to be 9.8 meters per second per second. And then the beginning velocity was u, which is from rest. We want to know what is v, right? The final velocity after those 4 seconds. Okay. So the equation that we're going to use is v equals u plus at. Okay. That's our Suvat equation. Okay. So U is 0, A is 9.8, and T is 4 seconds. So this would be 9.8 meters per second times 4 seconds. So you get 39.2 meters per second. Okay. Does the answer make sense? Yes. The speed changes by 9.8 meters per second every 1 second, right? So if we take 4 times that, we're going to get how far did it go? How far did gravity pull it for 4 seconds? Okay. What is the displacement of the rock at 4 seconds? Okay. So the displacement is then S. So now we're looking for S. We still have all the same givens. Remember, we want to look at our Suvat equations to find the one that has these 4 letters in it. Okay. So T, A, U, and S. So anything that has a V in it, we can't use. So we can't use this one and we can't use this one. Okay. We also need to make sure that we have acceleration represented. So that means this is the one that we're going to use. Okay. So S equals U times T plus 1/2 AT squared. Okay. So this would be U is 0. 0 times anything is 0. So this beginning number is 0. Then we have 1/2 or 0.5. A is 9.8. And then T is 4. And then square that. So 1/2 times 9.8 times 4 squared comes out to 78.4. And then it's distance, so it's meters. Okay. And then does this make sense? Yes, the distance changes 9.8 meters every 1 second, right? So every 1 second squared, right? So 4 squared, we change by 9.8. Okay. And then there's this 1/2 factor that comes from um, the, like if you were to graph it, you end up with the area of a triangle. So that's where that 1/2 comes from. Okay. All right. So to sum it up, acceleration during free fall is called acceleration due to gravity. The constant number, that number will never change and you have to memorize it. G is equal to 9.8 meters per second on Earth. Okay. It can be different for different places. Mars, the moon, Jupiter, outer space. Okay. So just keep that in mind.